In this video series, we're going to do some guided exam question practice. Now, exam questions can be quite daunting when you start them first because they're quite big and chunky and bulky and lots of text in them. And it can be really easy to misread something or to forget to do a part or to not understand what the question means. So we're going to be taking questions and helping you guys to break them down into small, simple pieces. We know the factual information. It's about learning the skills of answering exam questions here. And because this is the first video in the series, we're going to do a quick summary of the timing of the exam. So in the leader started chemistry exam, you have 3 hours to complete it. And 3 hours is 180 minutes. And in 180 minutes, you have to complete 8 exam questions. This breaks down to roughly a timing of about 20 minutes reading time. So we've got about 20 minutes to read questions and choose which ones you're going to do. And then you've got about 20 minutes per full question. So 20 minutes per question. Okay, so in this first series, we're taking a look at some of the atomic structure questions. So in this video, we're just going to look at the atomic structure question that came up in 2021. And as you can see, this was worth 25 marks down here in total. So this represents a half question. So a full question in chemistry is worth 50 marks. So this question here represents a half question, which means you've got about 10 minutes to complete this question here. So what we're going to do is we are going to start actually tackling this question now. So I'm going to help you read it and I'm going to help you break it down into its individual pieces. And what I would get you to do now is pause the video and go and find yourself a timer somewhere. So do that now, pause the video and do that. Okay. So what we're going to do, now that you've got your timer, what we're going to do is we're going to start it and I'm going to be asking you to pause the timer at different stages. So we're going to go ahead and start the timer and we're going to start going through this question. Okay, so start the timer now. Okay, so we're going through here. Let's read what it says. According to the scientific method, an existing theory is replaced when another theory can better account for certain experimental observations. Nothing important there. Some important stuff coming up, which I'm going to highlight, and I suggest that you get in the practice of doing this as well. So the first thing it says is John Dalton's atomic theory. Okay, so this is important information. That's a person's name and something that he did. So that's definitely important. John Dalton's atomic theory of 1808 was replaced around 1898 by the plum pudding model. So this again is a significant piece of information of the atom after the discovery of radioactivity and work on cathode rays. All of that is important factual information and it might mean something in the question. So I'm highlighting it. This model of the atom was in turn replaced around 1909 when Ernest Rutherford, there's another person, his experiments provided evidence for the existence of the nucleus and the electron cloud. So some of that might be important later on. So I'm just going to be able to draw my eyes back to what I think is important. Okay, now we have a question. We have a part one. This is where we're going to actually have to do something. Part one. The photograph shows wooden balls used by John Dalton again to represent atoms. This is where the question is. See, this can be quite tricky that the question is separated and we mustn't miss the question, okay? And when we're interpreting a question, it's really important that we read what it's asking us to do. So it's asking us to say what. What was Dalton's atomic theory? So we're going to go ahead over here now and we're going to start answering this. So it's really good to get in the habit of keeping your question organized. So this was part one. It was Dalton theory. So I'm just keeping myself a little tab on it. So again, it's a really good practice to get into this by writing Dalton's theory. If you get into the practice of doing all your exam questions like this, it's like an extra layer of revision. You're linking ideas by putting down what the question is asking for and then your answer. So what I'm going to get you to do is pause the video and write down what you can to summarize Dalton's theory. Now, how many marks is it worth? We don't know how many marks it's worth. It doesn't break it down for us. Some questions, as you'll see, some years it breaks it down and tells you how many marks that's worth. So it's hard when it doesn't do that, and this is the most recent exam, it's hard when it doesn't do that to know how many points they're looking for. But I would estimate they're looking for maybe 2 to 3 points here, probably 3 being safe enough. So see, can you get 3 of the main points about what Dalton's theory was? Pause the video and do that now. Okay, so you should only be playing if you've written down your summary of Dalton's theory. So what will I say is probably a good answer here? Well, what do we do in class? We talked about, okay, what did Dalton say? Dalton said, first of all, that all matter, or all substances, you could say, all matter is made of atoms. That's the first thing he said. That was the idea. And then what did he say about atoms? So all matter was made of atoms. What else did he say? Now that I've started you, if you weren't able to start it by yourself, you have another chance to pause the video and see, can you write down 2 other things that he said? Okay, if you got it already, great. If not, pause the video. Okay, so what else did he say? He said atoms are tiny, or another word you might have used here is minute. Atoms are tiny or minute. And he also said atoms are indivisible, meaning cannot be divided. Indivisible. One more thing he said was that atoms of the same element are identical. So again, hopefully you got at least 3 of them points. Now at the end, we're going to use the marking scheme to correct this and see would this have got us all of the marks. Hopefully you've got 3 of these. If you are taking my answers down for stuff you didn't get, you should do it in a different color so that you keep it separate and you remember what you actually knew, because we don't want to give ourselves marks when we're correcting for something that you didn't know. So try and keep anything you take down and copy from my answers in a different color. Now I know we're going to go a little bit over the 10 minutes that we agreed on here, because this is the first video I'm explaining in a little bit more detail how I would do the question, maybe a little bit more detail than I normally would, because it's the first video. So don't worry too much about the time, but it's a good habit to get yourself into to know how much it took, how much time it took. All right, let's go back to the question and see what part 2 was. Okay, part 2. So here you see, I'm going to use a different highlighter to keep it separate. Part 2 says name. All right, so it's asking us to do something, it's asking us to name. So all we're going to need to write here is a name. Name the scientist whose work on cathode rays, that's important, led him to, what did he do? Identify the electron. Okay, so that's the question. So the question, part 2, name. And it's identified the electron. That's what we're looking for, the guy who identified the electron. Okay, all right, so pause the video and write down, who do you think identified the electron? All right, so if I remember correctly, and I'm hoping that I'm going to get this right, the guy who identified the electron was J.J. Thomson. Hopefully you wrote J.J. Thomson. If you didn't and you're changing it now, make sure you use a different color. Again, we're going to correct that later. All right, let's go to part 3, because remember, we're on the clock here. We've got 10 minutes. All right, so in an orange highlighter, we're looking at part 3. What? So we have to describe what. What happens in a radioactive nucleus during beta decay? Okay, so that's important. We're talking about beta decay. Okay, so what is part 3 asking us to do? So again, you see I'm keeping it organized. Part 3 is talking about the nucleus. And it's talking about the nucleus for beta decay. So what happens during beta decay to the nucleus? So pause the video and describe what happens to the nucleus during beta decay. All right, so you should only be playing if you've written down what happens to the nucleus during beta decay. So this is what we should have said. During beta decay, a neutron splits into or turns into a proton. We learned that that proton stays in the nucleus and an electron is emitted. Okay, so they're the 2 things that I remember happening when a nucleus undergoes beta decay. All right, so again, like I said, we're going to go back and correct those in a little while. All right, now we've got another blurb or another piece of text. Okay, and we've got to again sift through this and see can we find some important stuff. So I've got a green highlighter. The measurement of relative abundances of isotopes of an element was first demonstrated by Aston in 1919 using a mass spectrograph. Don't think there's anything too important there. His results indicated that 90% of neon atoms had a mass number of 20. So 90% was neon 20, or neon with a mass of 20. And I'm changing the color now. And the remainder had a mass number of 22. Well, that's definitely going to be important. What would the remainder be? If 90% was neon 20, the remainder, okay, well, that must be, okay, that's too fat, that marker, sorry. I'm going to change to something thinner. The remainder must be 10%. 10% if it's the remainder was neon 22. I'm guessing, if they're giving me them numbers, I'm guessing I'm going to need them later. Okay, it was suggested at the time that neon 20 had 20 protons and 10 electrons in its nucleus. That's ringing a bell with me. That doesn't sound right. 10 electrons in the nucleus, no electrons in the nucleus. So this was obviously an old idea that's not right anymore. And another 10 electrons in the electron cloud, while neon 22 had 22 protons and 22 electrons with 12 of these located in the nucleus. Right, well, that sounds really wrong. So let's see where this is going. In yellow, this explanation was changed in 1932 when Chadwick discovered the neutron. Okay, so now that we've seen the blurb, it's time to look at what is the actual question. So the question isn't actually in there, but some important information might be. So we're doing part 4. What is the now accepted composition? And this word composition, we should know, means makeup. What is it made up of? What is the makeup of it? Of a neon 20 atom and a neon 22 atom in terms of subatomic particles. Okay, so I need to say what subatomic particles are in a neon 20 and a neon 22 atom. Okay, so we're in part 4. Oops, right, part 4. We're doing neon 20, and then we're doing neon 22. So I want you to tell me how many of each subatomic particle are in each of these. So pause the video and do that now. I'm confident you guys can do that. All right, so you should only be playing the video if you have done this, right? So it's neon 20. So you might need your periodic table. If you didn't think you'd need your periodic table, you might. So you need to get it out, see what information you can get about neon. Okay, so pause. So we have neon. It has an atomic number of 10. Okay, that means it's got 10 protons. And if it's got 10 protons, it's got 10 electrons. And this is neon with a mass of 20. So that means it's got 10 protons and 10 neutrons. So well done if you did that. If you don't know how to do this, then I suggest you go back to the video where we did subatomic calculations. Okay, neon 22 then, well, it's still neon. It's still got an atomic number of 10. So it's got 10 protons. It's got 10 electrons. And it's got 22 minus 10, it's got 12 neutrons. Okay, well done. If you got that right, I think that's going to be correct when we go to correct it later. And then we're going to do part 5, obviously comes next. There is another part. It says calculate, so different highlighter again. I'm going to do all this dark blue. Calculate the relative atomic mass. Oh, that's not a good color, sorry. Go this lighter blue. Calculate the relative atomic mass of neon using Aston's results above. So the fact is telling you above, it means you need to go back to your question. Now, relative atomic mass, we're going to need a formula for this that we need to remember. And we don't have it in the log tables. So we do need to remember this. So what we're going to be finding is relative atomic mass. Now, without looking in your notes, I want you to pause the video and see, can you write down the formula that we need to use? Pause the video, do that now. Okay, hopefully we're able to write down the formula. The formula for the relative atomic mass, we do the percentage abundance times the mass of isotope 1 To this, we add the percentage abundance times the mass isotope 2. And if it was a third one, I could add that on as well, but I think there's only 2 here in the information we were given. And whatever we get there, we divide all that by 100, and that will give us the relative atomic mass. So now that we have that, here is your information. Pause the video and go and finish that sum now. Okay, so you should only be playing if you have this finished. Okay, so what were we told? We were told that we had 90% of the mass, the neon with a mass of 20. So 90 times 20 was isotope 1. And then the rest was 10% of it, of the neon is neon 22. Sorry, I need to get rid of that percent. Sorry, I don't need that there. So 10 by 22. And all of that we take and we divide by 100. Okay, and now that you have that done, you get your calculator out, you're going to get the answer 20.2. Little tip here. This answer should be somewhere in between these numbers, because essentially it's a type of average. So if you got a number that's way outside of that, 35 or something like that, 35.7, well, that's not in between these two numbers, so you could be pretty sure that that's wrong. So the fact that 20.2 is in between 20 and 22 is a good sign that we've probably done this right. Okay. All right, so I want you to stop your timer. You are now finished that. Now, I know we may have gone over the 10 minutes there, but I was going quite slow today because this is the first video and I'm introducing things slowly. All right, so we're now going to use this marking scheme here to correct our answers, okay? So the first thing is part 1. So let's find part 1 over here. Here's part 1. What was part 1 worth? Part 1 was worth 6 marks altogether. You needed any 2 of these points here for 6 marks, okay? So let's look at what it's composed of. Let's see what the first point is. The first point is we can have, see this little single line here, means you can have one or other of these. So the one that came before this dashed line or the one that came after this dashed line. But you can't give 3 marks for each of these, only for one or the other, okay? So what are the 2 options here? Matter is composed of atoms, or atoms are tiny particles. Okay, looking at our answer, we actually have both of them. All matter is made of atoms, and atoms are tiny or minute. We've said those. Matter is composed of atoms, atoms are tiny particles. We've said both of those, but we can only give marks for one. So isn't it just as well that we wrote more than just them 2 things? Okay, what else does it say? Atoms are indivisible. Okay, so you see here, atoms are indivisible. And what have we said? Atoms are indivisible. So there's our second 3 marks. And that's the maximum marks we can get here for this section. Now we did have this one here as a bonus. Atoms of the same element are identical. And that would have also been a scoring point. But because we've already got 6, that's the most we can get here. So we've got 3 and 3. We've got 6 so far, 6 out of 6. Right, moving on to part 2. We have to name who identified the electron. So here we see the correct answer, J.J. Thomson, and we have J.J. Thomson. So that's an easy one. That's correct, 3 marks. Next one, what happens when in the nucleus when nucleus undergoes beta decay? All right, so what are they looking for here? Again, it's what, 2 times 3. So they're looking for a neutron changes into a proton, and then this double line means you have to have both the one before and the one after. So the neutron changes into a proton and an electron, which is emitted. Okay. So we said a neutron splits into a proton. Here we go. There's the first 3. And an electron, which is emitted. Now, this is where it gets a little bit funny, because I never said, this seems really funny, but it says neutron splits into a proton. And then I've said an electron is emitted. I haven't said that the electron came from the neutron though. So I probably shouldn't have done a bullet point there. What I should have done is continue that as a sentence. And an electron is emitted. So now the sentence reads better. A neutron splits into a proton and an electron, which is emitted, is probably what I should have said. So I'm going to be really harsh on myself here and not give myself the 3 marks for that. And an electron, which is emitted. All right, so what I'm demonstrating to you here is how accurate we need to be with the marking here. So we're not going to get that second point. I'm being super strict there, but this is the standard that we need to get to. So a neutron splits into a proton. I am getting those 3, but what I said before wasn't making it clear that the electron came from the neutron splitting into a proton and an electron. I just said an electron is emitted. Well, where did it come from? So I wasn't being clear. So I'm being super, super strict with myself, and you guys would need to do the same. Maybe you said it right. A neutron splits into a proton and an electron. If you did, you can give yourself them 3 marks, and well done. Okay, on to the next bit. All right, so I'm annoyed now that obviously, I'm obviously demonstrating to you the standard, but I would be annoyed if I had done that in the exam. Right, the next one. What is the composition of neon 20? Well, first of all, it's 10 protons, 10 neutrons, 10 electrons. So this is neon 20. Let's check what I had. Here's neon 20, 10 protons, 10 electrons, 10 neutrons. Well, that was the same. And what was it worth? 2 by 3. So here's a 3 mark. All right, and then the second one in orange, neon 22, 10 protons, 12 neutrons, 10 electrons. 10 protons, 12 neutrons, 10 electrons. So again, perfect. That's 3 marks. And then the last one, as you can see here, we've got purple here. Calculate, the answer is 20.20, 20.2. That's what we got. Look at what they did. The abundance by the mass plus the abundance by the mass of each isotope. They took that answer that they got here and divided it by 100 like we did, and they got 20.2. So you see here, the examiner has room to give you half the marks if you just did a bit of it right. But we got it all right. That's the answer that we got down here. So that's worth how many marks? That is worth 4 marks. So this is, sorry, in red, this is what 4 marks. All right, so I'm going to go ahead and add up my marks. I know I lost 3, so that gives me 22 out of 25. Hopefully you got 25 out of 25 and you didn't make the mistake that I demonstrated above. Okay, so this gives us 22 out of 25. Just for context of how much this 25 is actually worth. This 25 represents 1/16 of the whole exam paper, or 6.25% of the exam paper. Okay, so the whole exam paper, 6.25% of this question, sorry, was 6.25% of the whole paper. All right, so I'm hoping that you can see that exam questions are very manageable and that we have done this stuff in great detail, but that we do need to have a really high standard for ourselves when we're actually marking, because the examiner is going to have a high standard for themselves. I hope you can see that it's really beneficial to watch these videos of how we break the questions into sections, because if you just look at the whole question, it can be quite daunting. There's lots of information. It's really easy to miss something. So I'm modeling for you guys here how you should actually break it down and pay attention to each individual part, one bit at a time. All right, guys. So that's been the 2021 question on atomic structure, and I will see you in the next one. Thanks, guys. Bye.